Hello, this is ECE 637 Digital Image Processing 1, and I'm really excited to have everybody here. I'm really excited to have people in the classroom. It's kind of good to get out of my house because I feel like I've basically been in one room in my house for about 9 months with Zoom blaring at me. And, and it's sort of nice to see human beings again. But for those of you in the studio audience outside who are watching this via streaming web, we're glad to have you here too. And we have it. Oh, I should say that we have a TA for the class this semester, which is really terrific. Wen Ri over here. I don't know if you can. Maybe you want to come up here and just say hello real quickly, because that's always kind of a nice thing to know who it is that you're talking to. And Wen Ri will be TAing the class. I can. Wen Ri, there you go.
My name is Wen Ri. I'm the TA for this semester, and you can call me Lee or Wen Ri.
And Wen Ri he'll be available via email, and we even have a thing. I'm toying with an idea of like using. We've been playing around with a piece of software called Gather. Does anybody use a thing called Gather before? It's kind of free, and you can. It's like you can go into a little room, and you have a little avatar that you move around. So maybe we can do that for office hours, and also, yes. So the class. Let me see. I think maybe I should. Oh, I got a lot of emails about Brightspace. I apologize for that. There's apparently a hidden little button you have to click in order for the Brightspace site to appear to the students. Otherwise, it's hidden for some reason. It defaults to being hidden. So I clicked that button last night. But then if you go to the Brightspace, you may be a little bit shocked to see that there's nothing there. So I don't really use the Brightspace, except for, Wen Ri, will you probably use it for grading? I mean, for distributing grades and things like that?
Yeah, some people, I think they are using the Brightspace to send out the homework and collect the submission and grading.
Yeah, so we may use it for distributing grades and maybe even collecting homework. I'll coordinate with Wen Ri on that. But the course is basically run through the website that's that I directly control and edit. So actually, there's a couple websites. So I could show you those websites first. So hold on. I guess we'd switch over to the computer. Google Chrome. So Craig, add browse as guest. What the heck? Okay, I guess I'm a guest. Google, right? There we go, Google. And that's 637. Okay, so this is the class web page. And obviously you can get it. Oh, we have a little inset picture there, which I really like. So we can get it by, just Googling 637 and my name will come up. So I just updated this. There's, I haven't enabled the Piazza. I got to do that. One of the things is that, so video lectures for 2011. These things bring you to YouTube. So there's videos on YouTube from previous lectures. And I have to actually figure out the logistics. That's one of the things I wanted to ask about before I came in, but I forgot how I'll post these. So I guess people in the past semesters, the engineering professional education, EPE people, who are kind enough to be hosting this. By the way, you're lucky because this is part of this class is part of the EPE program. We have really nice people over here who do a really great job of collecting the video and everything and distributing it. So I think the quality will be better than I'm sure the quality will be better than if you, like for some other classes I'm using a thing called Boilercast, which you probably have used. How many people here have used Boilercast? Okay, so this is going to be better than that because the video is more professionally collected. I'll be using the document camera here a lot, and then also the web page, and you can see my face, which I think is helpful when you can actually see a person, and you can ask questions if you're here, which is really great. So, and I encourage you to do that, okay? But the details of how I distribute the video for people who aren't here, of course, this is a little bit like I'm like talking to people. There's a chicken and egg problem. Any instructions I give here are not helpful for a person who can't watch the video, right? So, but I think what will probably end up happening is I'll send an email out that has instructions on how to get access to the videos. I think for the people taking it as an online course, they get that information automatically, at least in the past. But for the on-campus students, I usually send out a link with a code for you to get access. I assume that they're still going to allow that. So, but I'll stay tuned on that. And I said, but the videos, yeah. But yeah, and I'm not even exactly sure where the videos are going to appear. I don't know if they're probably directly available from EPE. But in any case, so yeah. So now this is the main website for the class where most of the information is, and we'll have videos obviously this semester, but you can always go back and look at videos from previous years, okay? And there's also this Piazza thing, which you guys are probably familiar with, but I haven't set it up yet for this year. And the function of the Piazza is mainly for you guys to communicate with each other. We don't really, yeah, it's mostly for you guys to communicate with each other, okay? The course information, so let's see what we got here. So this is, basic course information. Let's see what it says. I actually have a printed version of this, but okay, this can't change. Hold on for a second. I need to reload. How do I reload? What happened? Something's wrong. For some reason, I updated this, but it didn't change. Okay, I'll have to fix it. It's odd. It's not DU, it's Wen Ray. So I just introduced you to him. Huh. Okay, I don't really know why that didn't update. But anyway, so this is this is the instructor. Okay, I'm just trying to see. Prerequisites for the course. That's something important. So people often ask me what I need in order to take this class. So basically, there are three major components that you really need in terms of preparation for this class. One is some background in linear systems. So if you're an engineer, if you were an undergraduate, this is a graduate course, so most of them, I assume, are graduate students. But if you've taken a undergraduate like linear systems, which would be filtering, linear time invariant filters, a Fourier transform, that's great. If you're not an electrical engineer, if you're like some other kind of engineer or not an engineer at all, then you'll want to have some background in the Fourier transform. I know that like Math 527 teaches that material. So for non-electrical engineers, that's an appropriate course to come up to speed. And in addition, I'll provide some, we have some supplementary references here. The undergraduate, so here at Purdue, the course is 301. So if you get the textbook from that, you can catch up. But it's linear systems, a little bit of probability, some kind of probability course. Most people, even if they're not, I mean, non-engineers these days, or most people have some kind of probability. There's a little difference between probability in the sense of statistics, which they often teach in like sometimes in the life sciences or in if you're I don't imagine we'd have a lot of people with a liberal arts background, but I mean that's fine. But like if you were doing psychology, would be more then they'll teach statistics. So that's you have to kind of look at what the courses cover. Sometimes the names can be a little misleading because statistics can mean different things. But if you're learning basically how to analyze data, that's not quite the right background. What we're looking for is like something more really probability, which is learning about probability distributions, random variables, that sort of thing. Okay? And then the third thing is some computing background, some software experience. And this semester, I'm going to ramp up the software component of this class. I'll talk about this some more later, but my goal is to convert this course. Currently, in this course, we use C. We don't use C++, but you're welcome to use C++. We use C, and we use MATLAB, okay? But I really want to convert the MATLAB component to Python, which is definitely where everything's going, okay? So let me be very clear. You need that in your career and your work and your research, Python is where it's at right now, okay? I mean, everything about computing always changes, so nothing's true forever. But right now, that's, MATLAB is used a lot. It's like a legacy, I kind of feel. Okay, it's a little bit like Fortran, okay? But it's not the future. Sorry, okay? I don't want to hurt people's feelings. Python is much more. So I'm going to try to convert some of that over. Now, a lot of people complain about C because C is brutally difficult to program in, okay? But I make no apologies for it. You're going to have to learn how to program in C. And that's one of the things I think you'll get out of this class. And a lot of people who can program, who come from a more applications-oriented background, who can program in Python or some language like that, can't program in C. And because the techniques for doing it are quite different, okay? So, oh, shit. No wonder. Okay, hold on for a second. I don't know how you turn this stupid thing off. Just a minute. My phone was ringing. Okay. It's probably spam. Okay. Shit. Phones are a blight on society, I think. Okay. I don't even know how to turn the damn ringer off.
Okay. On the left side of your phone, there should be a little switch.
Oh, there it is. It went down, but I had to log in. It wouldn't let me do that until I logged in. Okay, good. I hate cell phones. Sorry about that. I know, I don't want to hurt anybody's feelings, but I don't like cell phones. Okay, anyway. C is really important to learn how to program in C, I think, still. And the reason is that, and I think it's going to be that way for a long time, okay? And here's why. C is way more efficient, okay? But C is sort of like, it's a little bit like using a chainsaw, okay? Like, a 50 horsepower chainsaw without a chain guard. It's very powerful, but can be very dangerous, okay? So you need to learn how to program in C because it's so much more efficient, but you need to learn the techniques because it's easy to do something using bad programming style that creates bugs that you spend endless amounts of time. So I really want to emphasize programming at C, okay, and learning how to do that and learning the culture of programming in those environments, okay, because a lot of it is cultural, getting used to it. Some of you may come from a computer science or computer engineering background, and you may be more familiar with that. Although sometimes even students who come from that background, they tend to be more exposed to things like Python and so forth. So they don't get as much background in just, basic C programming. So you'll learn that in this class. So 3 things: linear systems, probability, and programming. If you have 2 if 2 of those 3, you should be fine. Okay. If you only have 1 of those 3, then you'll have to work extra hard. And if you have none of those, we should probably talk. Okay. I never tell any student wants to take the course, I'm supportive, but you want to be a little realistic. So, but I think we have a very diverse background of students. So we typically have students from civil engineering and biology and chemistry and things like that. So, hopefully everybody can get something out of it. Okay, so that coming back to the computer. The labs. We have labs and homeworks. We have lab homeworks. Okay, so we have the lab we turn in, and and we have a schedule. Actually, I should look at the schedule, the syllabus. Okay, so these are the labs, and I won't actually remind you when they're due. Okay, so you have to remember. How do I get this thing to make it bigger? So save as. Computer's a bit slow. Desktop. Save. So you need to follow this, okay? It's your responsibility to, what the heck? What did it do? Okay. I'm not allowed to not want to do this? Why do I have to? I don't understand. If I put X, it makes it go. Excuse me?
Go back to the browser.
Yeah, you can go back on the browser and just.
Next out of it.
Oh, just X this?
And then just put you see the square on the top right of the window?
Here?
Up.
There?
Square.
There you go.
No. And then you can.
Oh, okay.
Then you can zoom in.
So I can get most of the stuff this way. Okay. Where's the zoom in feature?
It should be in the bottom right corner of the thing, or if you. Control plus.
Oh, that'll do it. Control plus. There we go. You know what? I'm going to use my laptop after this because I'm going to have to in order to do a lot of the things having to do with programming, demonstrations, and so forth. The point here is that the labs are due. So one of the labs is due not this Friday, but next Friday. Any lab that you want to do in Python is fine, okay? So if you prefer to do it in Python rather than doing it in MATLAB, this first lab is actually C, okay? So there's not an issue, but the second lab here, 2 weeks from now, is in Python. I think we're going to try to convert as many of them over in terms of the instructions, but I need to see how far we get. But with so I'll talk about that a little bit more later. Here's the list of topics we're going to be covering. I'm going to talk about that in a minute. But one of the last topics we do a little bit of deep learning stuff. But the important takeaway here is you must remember when these are due. That's your responsibility. Okay. And I think in the past, the way we've collected these labs is that people would email us PDFs. Maybe you and I will coordinate on how we want to do that. I have instructions here for how to hand them in, but we might be able to update this protocol to make it easier to hand stuff in. Hold on. Oh, control. I did the wrong thing. Excuse me?
I think it's very easy to do this in Brightspace.
Okay, so you think we'll be handing everything in Brightspace?
Yeah, I think we can.
Okay, so I'll update these instructions to say that. So ignore this part. We're not emailing this stuff in. We'll submit it through Brightspace. Wenry will get back to you with instructions on exactly how to do that. Yep.
So in general, if there's a section for MATLAB, we can replace that with Python.
Yes.
Okay.
I'm giving you. That's my official dispensation, whatever. You're allowed to do that, okay? So in fact, we're going to convert them over with time. But if you just want to do it yourself, just do it. Okay. You have to use obviously some reasonable judgment in what it means to convert from one to the other. So you have to produce the same results that it's asking for. And I'll go over the websites for the labs in just a few minutes, and we'll talk about how you do the labs. Okay.
And so we're free to use the libraries that are available and accessible for image processing. Okay.
Within reason, which is of course a very squishy thing. So, like you're allowed to use the equivalent functionality from it's the same thing in MATLAB. So if there's some function in MATLAB which performs the entire lab with a single function call, you're not allowed to do that. Okay, you have to construct the solution yourself. Okay, and NumPy has, as I'm sure most people know, basically very similar operations, almost one-to-one analogies, FFTs and so forth. So just use the equivalent things. We're going to convert things over. I'll talk about that a little bit more in a minute. But if you have do you have another question? Because those were excellent questions. Okay, so I do want to go over some of this. Course objectives. I always say there's 3 course objectives in this class. One is to I want to teach you the theory of image processing. Image processing is different than signal processing because it doesn't just involve generic processing of signals. It involves processing of a particular type of a signal, which is an image. And of course, the question is, what is an image? Well, in a strict sense, in a strict interpretation, you might say people usually interpret images to be like pictures, something you take, a photograph you take with your digital camera, say. Okay? But, more generally, we're going to see that images are things like in medical imaging, if you have a CT scan, what you're really doing is you're visualizing some underlying property of the world, right? So if you have you're doing atmospheric sensing and you have a 3-dimensional volume of the carbon dioxide concentration, I'm just making this up, you can visualize that as an image. It isn't really an image. There's nothing to, you can't see that with your eyes, okay? Or if you have an electron microscope and you're looking at the atomic structure of a virus, okay? You can't see that with your eyes. But you can produce things that are images from it. In that case, it's more of a visualization task. And really, the dirty little secret in all this is that, I use image processing as an excuse because it's more interesting to people than signal processing, because images are more interesting than signals, I think. So really, everything's an image, okay? So, a signal is just a one-dimensional image. So, I take a liberal interpretation, and but there's a lot of culture associated with images. There's a lot of know-how. Okay, it's like when I guess people still get their cars fixed, right? That's a thing, right? My car breaks, I bring it into the mechanic and they fix it, right? I like working on cars and stuff, but if I have to fix it, it takes me like a ridiculous amount of time. The mechanic can do something in an hour that takes me 3 days, okay? And then I have all the wrong parts, and I go back and forth to the store, and everything's broken, okay? Because the mechanic has a lot more know-how than I have, right? They do it every day. There's this book about I forget what it's called. I'm sure Malcolm Gladwell or something like that, about the 10,000 hours. If you do something for 10,000 hours, you become an expert at it. You just know all the ins and outs. So part of what we want to teach is the technology, sort of the ins and outs, getting used to it, understanding what the applications are, what the issues are, what the problems are, how people get around it. You won't put 10,000 hours in, hopefully, in this class, but you'll get used to it, okay? And then the other thing, which is super important, and I'm going to even be emphasizing it more, is, some of the stuff, Vi's laboratory, that's not even a thing anymore. But I even forgot, I should delete that. You want to learn about how to use computers. So this semester, I've decided, I'm definitely we're going to do a lot more software. We're going to do Python. I want to introduce you to things like Git, okay? Because Git is this thing. How many people know what Git is? How many people don't know what Git is? Okay, so Git is the way software gets developed these days, or at least things like Git, okay? And so a lot of software like Linux is all open software development, and even if you work for a company and they have proprietary software, they'll use these same kinds of tools. So I want you to get some exposure to it, some familiarity. We're going to use it. I'm going to teach it, okay? And so learning how to program in Python. See, the big thing, the problem with MATLAB is that there's a few problems. First of all, the language was developed a long time ago, and it's not kind of a modern language anymore. But the other problem is it's proprietary. So, it's free for students, but once you go outside of the university, they charge you a lot of money for it. So it's really difficult. If you develop things in MATLAB, it doesn't get very wide distribution always because people can't use it. It's also not nearly as interoperable, okay, because of things having to do with the design of the language at a fundamental level. So Python allows a lot more interoperability. It's open, it's free, and it runs. It's very good in terms of being, or compared to alternatives in terms of being cross-platform. Cross-platform is always a challenge. So, and there's a lot of things available for it, like OpenCV and a lot of image processing tools. Okay, so the computer laboratories are 15% of the grade. Here's my thing about the computer laboratories. Everybody should be able to get 100% on every laboratory, okay? Because it's if you don't know how to do something, the TAs. Oh, by the way, hold on. I have, in addition to Wen Ri, I have a list of a bunch of other names. For some reason, it didn't update. I have to check the LaTeX file of other students who can help answer questions. Okay, they're volunteers. Okay, even Wen Ri is a quarter-time TA, so it's not like a super generous TA appointment. So be nice to them. Okay, they're doing their best. Right? It's not easy, especially a large class. Last time I checked, we had like 65 students or something. So be kind, okay? And then also you can definitely work with other students, okay? So this is getting into the academic policy issue, which is that every person needs to write their lab solutions themselves. But that doesn't mean that you can't work with other people. It just means you shouldn't use their code, okay? If they explain, this is what I did and here's what my code looks like, and then you rewrite it, okay, then that's okay. Or you work with them, you exchange ideas. When Ri or I will be happy to tell you the answers to the labs, okay? It's not a secret, right? It's only a secret in the sense that we want you to figure it out yourself so you learn it. Because if we just tell you, then you won't learn it, right? But everybody should get every lab 100% correct, okay? And it's not a huge part of the grade. So it's for you to learn the material. Then there's going to be 2 midterms and a final. Last semester, I used Gradescope to do them, okay? I'm going to use synchronous. Oh, I should have put some of this in here. It didn't even occur to me. I'm going to use synchronous exams, okay? So probably what I'll do is I'll make them early in the morning, like 8 a.m. So that, because I think when you look at the time zones that people are in, that's usually covers it, okay? If I make it early in the morning, it'll be, it'll have to be going, I'm going to have to think about it a little bit. Also, this is EPE, so they may have some proctoring capabilities still. But basically, they'll be synchronous. If the synchronous exam times don't work for you, let me know, and we'll figure something out, okay? But it's going to be synchronous. I use a thing called Gradescope. How many people have used Gradescope? Okay, so you've been exposed. The first time I gave Gradescope, it was a little bit traumatic for the students. So you have to be able to scan. The way Gradescope works is that I use the actual written solution. So you have to write it out on a piece of paper, and you have to have some way of scanning the piece of paper. I mean, you can use a cell phone as a scanner. I have a thing called Dropbox. Everybody knows what Dropbox is, right? Dropbox has scanning built into it, so you can just use this to scan, okay? But you have to have some way of efficiently scanning a piece of paper, or you'd have, I mean, you can, all I care about is you upload a JPEG or a PDF, okay? But you have to have some way of doing that, okay? So that, so make sure you're prepared in terms of having the infrastructure. And here's what I'm going to do, okay? Unless somebody tells me I can't. Okay, nobody's told me that yet, and I asked a few people, which is that I want everybody to turn Zoom on. Oh, am I going to be able to do it with ECE? Okay, I'm tentatively saying I want to do it with Zoom. Oh, EPE may have its own proctoring, okay, but I want some level of proctoring, okay. As Ronald Reagan once said, trust but verify, okay. Has anybody ever heard that before? Okay, I trust you all, but I want to verify, okay? Because it's not fair to the honest people if I don't do that, okay?
So it will be a closed book exam?
No, it'll be open book. It'll be open book, and it'll be synchronous, but I still want some verification, okay? But we'll work on that, okay? I think it'll be open book. I'll make a final decision. I mean, one of the things that I'm hedging on here is because EPE gives me more flexibility. If I can do a fully proctored exam, like you people come to class and people have proctors physically watching them, I'll do a closed book exam, okay? But my assumption is I'll probably do open book, okay? If I can't fully proctor the exam, I'll do open book, okay? But I still want to have some kind of level of synchronization and verification, okay? Is that reasonable? And if people, I'm saying this now, so if you have concerns, you can raise them early on, okay? Because it's not set in stone. Okay, final exam. Okay, academic honesty. I'm going to have to update some of this based upon some of these crazy systems for taking exams, which are in flux. But the main thing about the academic honesty policy is don't do anything dishonest, okay? So I think you should know what that means. I mean, obviously, during the exam, if someone emails you the answer to a solution, that's dishonest, okay? If you're working on a lab, you can cooperate with other people, that's fine, but you have to type in your own answers, okay? So if I get 2 labs and they're duplicates, your day you're gonna have a very unpleasant semester, okay? I mean, it's unacceptable, okay? And I'm gonna check that stuff. So we'll find people, I find people, and it's always a shame. I mean, I think I failed a person last semester. I'm pretty sure I failed a person. So you don't want that to happen, okay? Did you have a question?
Do you have office hours for questions?
It's by appointment, typically. But the Wenry will have office hours, and you can email me, okay? I'll update some of that information. Any other questions? Academic, okay, off-campus students, this is in flux. I'm going to have to update this. I have to talk to Craig, the EPE people, and find out what the protocols are for the exams. I was going to update that, and I forgot. I mean, okay. There's a lot of things changing this semester. Okay. Now, the labs. So the image filtering lab, the first lab, okay, so this is the web page for the labs. These are the labs for 637, okay? Which is the course I'm teaching right now. The first class the first lab is image filtering. If you have a background in computing, this is going to be pretty easy for you. If you don't, it could be hard, okay? So we have to bring everybody along. This is a laboratory procedure. It's in LaTeX, and basically it just says, what you do, and it says over here, this is what you have to actually do for the lab. It tells you, create a document, it's like a PDF, and you do the derivation of this equation, of this result, you plot that function, you print out this color image. When I say print out, I mean to a PDF, and then you list your C code, okay? And then there's every place there's a box is something you have to do, okay? So I think that, by the way, every semester I get these labs, people hand them in. They do very bizarre things, like they don't put their names on them, okay? And they don't put the name of the lab, and they don't put the date. So that's just standard protocol, right? You're handing the lab in, you have a title, the title of the lab, your name, things like that. The date. It's just obvious. It should be obvious, okay? Now, this semester, so here, I'll actually demo this in much more detail when I have my own laptop. But here's the GitHub site where you download the code. And and then this is the C code that you can use. So basically what happens is this. How many people here have never programmed in C? Okay, not too many. How many people feel they've programmed in C, but be honest, okay? They've programmed in C, but they're not real comfortable with it. They can do it if they really have to, but it's not their preference. Okay, about half the class. And also, here's the other thing. I'm basically expecting that you're going to be doing this in a Unix-like environment, okay? Okay, Wenri, make a note of this because I have to remember to do this. This is super important. We have to post instructions for people who have Windows. Macs basically are Unix under the hood, okay? So you can do it any way you want, but I want you to use the make files, okay? I want you to learn about standard compiling of code. So over here under source, src means source, there's a thing called a make file. The make file is the standard way of telling the computer how to compile the code, right? So look, it's not like I'm going to give you a 0, okay? But for your own good, I don't want you to go into like Microsoft Studio and do this point and click thing, okay? I want you to do it via the command line because that's basically how real programming gets done, okay? I'm looking over at Kenny because you could disagree with me if you think I'm wrong. People have like, WYSIWYG coding environments for doing certain things that people like and they're useful. But in the end, the real stuff gets done on the command line. So I want you to learn that. I know you've probably been, a lot of undergraduates are resistant to it because they don't want it, it's too painful, okay? So you need to like learn how to run a shell and run Unix commands in a shell. There's Windows, you can get a thing called bash. You can get a bash environment for Windows, or we'll maybe assume bash, which is sort of the simplest, not the cutting edge, but pretty basic shell where you can do commands in. Okay, so bash, or in the Mac you can, it's Unix, but you have to get compilers. So the compiler for the Mac is free. You can get a thing called Clang, which is the Apple compiler, or Windows. I don't know how it works exactly, but I think the university has a free license for Microsoft Studio. You download it or something. Or you can log into a Unix machine or run Linux, okay? And then one of the things, like I said, I'm going to actually spend some lectures and also teach you Git, at least teach you the basics of Git. I mean, it's not like I'm that good at Git, but knowing something about how Git works. This is GitHub. So GitHub is basically a organization. I don't know if I think it's a for-profit because it's part of Microsoft now. An organization that hosts Git sites. Okay, Git is the underlying software, and so it's I can teach you. I'm going to teach you the basics of how this works because this is how real software development gets done. All right. What else do I need to say? So I need to go back to the my site. Okay, so I talked about the labs. Now I want to talk about what the course covers in terms of topics. So I have these notes here. Let's see. So we're first going to start off with the continuous time and discrete time Fourier transform. So if you don't have a linear systems background, this part's going to be challenging. So if your background's like in computer engineering here at Purdue, the computer engineers learn linear systems because they take 301. But that's not true everywhere. So if you're like a computer science background or something, this may be uncomfortable for you. But that's okay, because later on in the course, you'll be laughing at the students who can't program in C and are going through excruciating pain. So that's fine. And then we'll talk. Okay, so we'll do the linear system stuff, and then we'll try to get into some applications to make it more fun. Yeah.
When you say linear systems, are you primarily referencing Fourier transforms? You've mentioned that a few times. Is there?
Yes.
What other topics from that are going to be useful for this course?
Do you have any matrix
What's your
theory?
background?
So I took electrical engineering in undergrad at Purdue.
Oh, okay.
Kind of focused in computer engineering, but I'm not like super strong on like Fourier transform.
Your background will be more than sufficient. Okay. So basically, if you've taken through one, you know what a linear time invariant filter is. You know what the Fourier transform is in 1D. Okay. And if you know what a discrete Fourier transform is, then you're really in good shape, okay? But some students have never heard of a linear time invariant filter. They don't know what frequency response is. For those students, they'll need a little more background, okay? But it doesn't need to be extensive. And if you're worried about that, you can come talk to me, and we can discuss it. I can put you to some references. But it'll be a little challenging for you in that initial part, okay? Okay, this is some C programming stuff. Oh, I know. Here we're going to do tomographic reconstruction and MRI, which are two applications that use the Fourier transform and linear systems theory. And these are medical imaging, but it also can be imaging for other applications. So, like if you get a CT scan because you broke your leg or something, that's tomography. So that's kind of cool stuff. And then we're going to get into discrete systems. We'll get into the sampling and discrete transforms, 2D discrete transforms, and we'll talk about eigenanalysis, which is really handy in high-dimensional systems. You know, it uses a lot in like data science and so forth. And there's an associated lab with that. Then we'll talk a little bit about image topology and segmentation. This is kind of a classical view. Of it. It basically helps organize your thoughts. And then we're going to get into color and image perception. So here, this actually has a lot of intersection with psychology, because here, engineers often like things that don't involve humans, because humans are kind of messy. But here you have no choice. We got to deal with humans because humans are the customer, right? You're looking at the picture with your eyes. So what does a human perception of an image? What is their perception? So we have to model human perception. And color is really fascinating, okay? Because, and one of the things that makes color really interesting is that you think of color as being a physical property of something, like this is a red pen. Well, the pen's not red, okay? What's true is that my perception of the pen is that it's red, okay? And you might say, oh, he's splitting hairs. But I'm going to give you some optical illusions which are going to blow your mind, because basically, I can make the pen look any color I want, okay, if I play games with it. So it's not just it's a matter of understanding the physics, understanding the mathematics, but understanding models of human response, of the perception. Okay, then we'll talk about resolution, conversion, interpolation, and decimation. Enhancement and filtering, things like denoising. And we'll talk about quantization and halftoning, which is a big thing in printing. And finally, we'll talk a little bit about image coding, which means compression, like JPEG and MPEG. Okay? Let me see. So what have I not covered at this point? I think so we have some introductory notes. I can start over here. Okay, I think I've talked about most of this, but I could go through it and it'll remind me if I forgot something. So I need to get back to you with a few things, like some details on how we're going to stream code and those things. Okay. Course objectives, I talked about this. Supplementary references. We talked about all this. Okay, I've sort of talked about this. Image processing interesting because it combines three things, right? It combines physics, mathematics, and then also modeling of human systems. Because humans are often, not always, but often the consumers of your output. So you produce some algorithm, it generates a high quality image on the phone, and then a person views it. Okay. Oh, I should, as a function of, as a matter of advertising, or marketing, the iPhone, like, you know how it has a night vision mode or a night picture mode or something like that? The person who led the team that created that took this class, okay? So there's a future for you. Also, okay, maybe how many people have does anybody have an Android phone that has the through the screen fingerprint detector thing? Okay, the person who developed that algorithm, okay, took this class. Okay, so we're going to learn things that can be valuable. Okay, yeah. So that's cool. Oh, some of this is old. Okay. Okay. The first camera is it over here. I want to hide it if it is. Oh, okay. This stuff always gets old. How much is it? If you buy it, first of all, nobody even buys a digital camera anymore. They just buy an iPhone or an Android phone or something, right? And it's just built in. But I have a camera at home I'll bring in at some point that's always fun to play with. A Nikon D810, and actually it was state of the art like 5 years ago. Now it's old, but it's a full frame digital SLR, and I paid about $3,000 for the camera body, or $3,500 for the camera body. So, but somewhere around here, I don't know where it is. I got to go find it. We bought like in the early 1990s. We bought a Kodak DCS 460C that was 6 megapixels. Okay, 6 megapixels. It was one of the first commercially available professional digital cameras. Okay, guess how much it cost for the camera body? And this was in like 1992, 93, something like that. A 6 megapixel digital SLR. How much it costs? Take a guess.
5,000.
Look, that it's higher. Someone guess. And this is in 1980. This is in 1992 dollars. Okay, so I don't know how much inflation has there been since then. Probably almost a factor of 2, I would think. Right? Take a guess as the price.
15,000.
Higher. For a 6 megapixel camera in 1992.
20,000,
Higher.
50,000.
It was $35,000, okay? It was $35,000, but it was $50,000 because in today's dollars it would be $50,000. It would be like, it was, today's dollars it would be like $60,000, $70,000. Okay? It was like we were hot stuff. Okay? We had this camera. It was very cool. So things have changed a lot. Okay? We're out of time basically. And then applications. Imaging has huge applications, obviously in medical and consumer. Okay, this is what $2 trillion company. Okay, that makes these things. $2 trillion company. Okay, in vehicle autonomous driving and everything is becoming images because images are ubiquitous sensing signals. This may as well just be called a class in digital sensing 1. Okay? The fact that it's an image is a detail. So, all right, it was good meeting you. This is our first pandemic version of the class, and hope to see you again on Friday.